Okay, guys, so for this little lecture here, we're going to talk about molar mass and dimensional analysis. This should be fairly straightforward and bring back lots of memories from when you've had this class before. All right, so let me just scroll to the next slide, and we'll go ahead and start. So what we're talking about here today is molar mass and how we find the molar mass of different things in AP chemistry. So what I have here at the beginning is an example. So we have iron 3 nitrate, that is our compound. And what we want to do is be able to take its molar mass so we can use that for dimensional analysis. When we are doing that, all we have to do is look up these individual elements on the periodic table and add those values up. So if I look on your periodic table, if you look there, iron has a molar mass of 55.85. So what I would do is I would take 55.85 times how many of those iron atoms we have, which is just 1. If I look at the nitrate compound here, you see that there's a 3 subscript outside the parentheses. So what that means is that 3 is distributed to the nitrogen and it's also distributed to the oxygen. So I have a total of 3 times 1, 3 nitrogens here, and I also have a total of 3 times 3, 9 oxygens here. So in order to figure out the molar mass of this compound, what I'm going to do is just add up all of these from the periodic table. 1 nitrogen has a molar mass of 14, so I would say 14 times 3. 1 oxygen has a molar mass of 16, so I would say 9 times 16. And once I add up all of those values, you should get something around 242 grams for every mole. I apologize for Rue barking in the background. She's playing. So 242 grams for every mole will be the molar mass here. Now, this is the most widely used way of figuring out the molar mass of something. But let's say you have something that's unknown. So you didn't know what the compound was, so you couldn't look it up on the periodic table. This is some type of questions that they will be able to ask you on free response questions and whatnot. So when you have that and you're trying to find the molar mass of something, there are some equations to help you do that. It all depends on what you're given. If you are given density, all right, so what you're given here is density. So given density. Density is mass divided by volume. So if you're given density, you have a special equation that you use to find an unknown molar mass, and we like to call that molar mass kitty cat. The reason why is, you'll see here, molar mass is equal to density times R. This R right here is your gas constant, which is 0.0821, times T, which stands for temperature, over P. This P right here stands for pressure. So we call this the molar mass kitty cat. I didn't make this up. I learned it from another teacher, and it stuck with me, so maybe it'll stick with you guys. Kitty cats, when they use the litter box, they put their dirt over their pee. So this is a good way to memorize this equation here because it is not on your equation sheet. The reason why it's not on your equation sheet is it's actually a derivation from the infamous PV equals nRT equation. I like to call this PivNert whenever we're working with this. So what this is doing is this is taking into account the moles, which is N, and the volume, because we know that density is mass over volume. And so this is a way to derive a molar mass equation from PivNert. So molar mass equals dirt over P. Density, R value, which is 0.0821 times temperature. That temperature does need to be in Kelvin, over pressure. So that's one way that I can find a molar mass if I'm given density. Another way that I can find molar mass is, again, this is an unknown compound. I can't just look it up on the periodic table. Molar mass If I have some sort of information that gives me the grams of a sample that will usually be given to you, we know when we say molar mass is something, it's grams for every mole. Well, that's grams over moles. So if I know grams of some sample and I can do some sort of stoichiometry to figure out how many moles is in that same sample, I can just divide the grams of that sample by the moles of that sample, and that relationship there will give me the unknown molar mass of that compound. I've seen that question asked a couple of times before. Now, let's look here at the bottom where it says hydrates versus anhydrous compounds. In your previous chemistry class, you might not have used hydrates before. Here's the difference between the two. This compound right here is copper 2 sulfate. So copper 2 sulfate. And this is what you see in this little watch glass here. It's a fine powder. The difference between this one on top and this one on the bottom is that this has a blue color to it because of the copper 2 ion. And if you had pre-AP, you had Miss O'Neill, you had Miss Till, there's always a question that says, what color is copper 2 ion? And then that's the blue. So that's what's giving us the blue color here. This is where not as much water has been added to this except for these little droplets here. So I have copper 2 sulfate, and whenever it is hydrated and you buy a stock solution of that, it's in these like cool little crystal shapes, all right? So this cool little crystal line little structures. This is a hydrate right here. This has water embedded within the structure. Okay, so it's still a solid, it's still a dry solid, but the water molecules are embedded within. So if I have water trapped inside here, then that obviously accounts for some mass as well. So the mass of this compound is going to be larger than the mass of this compound. So this is what a hydrate looks like. We say that it has dot waters. This little asterisk here should actually just be a dot. Now, how do I take the molar mass of these? Well, for this one, I just take the molar mass regular. I look up the molar mass of copper, 1 sulfur, 4 oxygens, and I add it together. For this one, I do the same thing, but I have to account for these waters as well. So I'm going to add the molar mass of this copper 2 sulfate, but then I also have to take the mass of 5 waters. When you are adding up molar mass, I have this question every year. Do we use coefficients to add up the molar mass? The answer is no. I never use coefficients except for when I'm working with hydrates, because this hydrate is one big compound. This is one big compound here. So I do need to add 5 waters to the molar mass of the copper 2 sulfate. And that's how I get the molar mass of these hydrates. If I were to have 3 dot waters here, then I'd add the molar mass of 3 waters. If I had 6, I would add 6 waters. And so you guys get the idea. So this is how we take the molar mass or find the molar mass of lots of different things. The next thing that I want to go over with you guys is dimensional analysis. How do I use that molar mass in the dimensional analysis? Well, if you remember, there's several different conversion factors. Your first conversion factor is that 1 mole of substance is equal to however many grams of that element or compound that we have. This is where your molar mass that you add up from the periodic table goes into play. For instance, iron has a molar mass of 55.85. So 1 mole is equivalent to 55.85 grams of that element. If I have a compound like the copper 2 sulfate that we were looking at, I would add up that molar mass, and 1 mole would be equal to that number grams of that compound. So you guys get the idea. Another conversion factor is if I'm going between moles and atoms, molecules, or particles. 1 mole is equal to 6.02 times 10 to the 23rd atoms. It can also be classified as molecules. It can also be classified as particles. Now, the last conversion factor that you are going to use is only at STP. Now, STP means standard temperature and pressure. That means 0 degrees Celsius and 1 atmosphere. And I'll talk about more about that for our next video.